Now in this video I'm going to explain you the question number 4, 5 and 6 are remaining. So the question number 4 says you have to draw a vernier scale. Okay, RF 1/25, read up to 4 meters, show the length of 2.39. So basically there are two types of vernier scales. One is backward vernier scale and one is forward vernier scale. In this scale everything is similar to the previous scales. Only the difference will be shown. I will tell you the difference in this scale later on. First, RF is given to you 1/25. Maximum length is given to you as 4 meter in question number 4, and similarly LOS will be equal to 1/25 into 4 meter to centimeter. You have to convert 25 and 4 means 16 cms, 16 centimeter. So first of all you have to draw a line of 16 centimeter directly as of normal plane scale. This line is of 16 centimeter. Okay, now you can divide this line into 4 equal parts by using the same method of making this. Taking any length of the arc and make 4 arcs on this line like this: 1, 2, 3 and 4. This would be your 4th arc, 4. Now you should earlier time you have to join the last 2 points of this arc. 1, 2, 3, 4. We have to, this is 4 meter, 16 centimeter is representing 4 meter. So we have joined this. Now we have to tight your vernier your drafter, and then make next line, then make next line, and then make next line, and then close this box as earlier, 5 mm box. So this is first division, second division, third division, and so on. Now for this first part you have to divide this into 10 parts as earlier in plane scale. Same situation is there. Make a line, divide this line into small 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These were the 10 parts as of your normal plane scale. Until this process you have to follow the same process until this step. You have to follow the same process of plane scale. You need to make your drafter parallel to this line, and then you have to make parallel lines by this point, like this. Like this. This. Again a parallel line. This completes your division of the first box as of normal plane scale. First, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. So this is your division of the first part. You can write it over here like 1, 2, 3, 4. Sorry, this is 0, 0, 1, 2, 3. 0, 1, 2, 3. You have to write something like this, and 1 again. Now as of diagonal scale we can draw this, and you can measure this distance 2.39. As you know, this is a 4 meter line. Every division is a 1 meter length. This is actually a meter. This is representing a meters. So this is 4 meter line. This is representing 1 meter. This is 0.1 meter. We need to find out 2.39. So it is not possible. So we have to make something else. So you just need to find out what is the width of the one division of this bracket. One division. This is coming out to be 4 mm. So you need to make another division over here, 4 mm. You need to make 11th part of this line, 11th part of this line, like this. 10 plus 1, 11th part. Okay. Then you have to close this in a box again as earlier. We have taken 11 part on the upper box. So now we have to divide this 11 box, one box, into 10 parts again. We need to make a line over here, and then we need to convert this box into 10 pieces. We have to divide this into 10 pieces. 1, 3, 4, 5, 6, 7, 8, 9, 10. 1 2 3 4 5 6 7 8 9 10. So now you should join the last point with the first division. First point, this point has to be joined directly. Now we have to take the drafter and align our scale to this, and then move this toward this point and make a line parallel to previous one. Then move this and make a line parallel to previous one like this. Then make a line parallel to previous one like this. Then make a line parallel to previous one like this. Then make a line parallel to previous one like this. Then make a line parallel to previous one like this. So then make a line parallel to previous one like this and like this. So you can see the divisions which are in the above panel are little bit above this division, because if this is a 0.1, this is 1 meter, this is 0.1 meter, so this would be 0.11 meter, this would be your 0.11 meter. So these divisions are certainly small quantity, they were higher than the previous division. So if you make exact system, then this is also 10, this is also 10, but we have taken one more part of this. So this one division equivalent to 0.11 meter, and this is 0.22, 0.33, so 0.99 meter, 0.99 meter, then it will become 1.1 meter. 1.1 meter. This division, this total length is 1.1. Okay, 1.1 meter. So this is 1.1 meter, this is 1 meter. So now we have to calculate 2.39 on to have to show it. So first we have to eliminate this 9. So we have to subtract something from 11, from the table of 11. From the table of 11 we have to subtract this large digit so that it should be eliminated from our dimension. Like if we want to calculate 3.34, then you have to eliminate 4. If we want to calculate 2.39, then eliminate 9. So subtract 0.99, so you will get 1.6 and 3, 1.40. We can also write 0.99 plus, you will get 2.39. So here is subtraction, here is just addition. So we have two quantities, 1.40 and 0.9. In order to find out 0.99, 99 would be this would be 99, this would be 1.1, this would be 99, this would be 0.9. Sorry, this is this would be 9, this would be 0.99, this would be 0.99. If you draw it well, because I am using the pen, it is not very perfect in its condition, you will get this as a 0.99. And You can count it also. 1 2 3 4 5 6 7 8 9. This is 0.99. If this is 0.9, this is 0.9. This would come like here on this position. So this is 0.9 and this would be 0.99. It is coming out to be very far, but this is manual mistake, so you have to be very careful while making this. So this is 0.99. okay, now 0.99 you can mark it here. This is 0.99 plus up to this distance it covers 0.99, and then you have 1.4. This is 1. This is up to this distance, it is 1. So this is 1 plus 0.99. I need 0.4 more. For that reason we have to divide this into 10 more division. I need 0.4. So we have to divide this into 10 more position, 10 more division. So I have taken, again I have to take a line. I have to take a line and make 10 divisions of this line. One, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. We are dividing this small box into 10 division like we have done in this case. So in vernier scale you have to divide all these boxes into 10 divisions if it is necessary. Now you should join the last point with this point as earlier. Okay, then you take your drafter and make it parallel to this. Now draw a line. I am making as perfect as possible, but still it will generate an error because my table is not that good and I am using pen which we cannot erase. So you can say I have made these 10 divisions again. So this is 1, 2, 3, 4, 'This is your 10 divisions. Now we have to take only 4 divisions because we need to complete 1.4. So 1 2 3 4, this is your 0.4 division. So this completes the distance of 1.4. So you can write it over here. This is 1.4. This total is 1.4, and this distance is 0.99. This distance is 0.99. So the complete distance would become 2.39. So you can extend this line and make it again over here. This distance, complete distance is 2.39 is the complete distance. And this type of scale is called as backward scale. Backward scale, it is a backward scale. And this is a question number 4. So I hope you had no problem in doing this, in calculating the measurements. Like you want to calculate 2.34, then you subtract 0.44, so this would become 1.90 plus 0.44, this would become 2.34. so this would be addition. So we need 0.44 from this and 1.9 from this, like 1 2 3 and 4 and 1.9 from this, like this is 1.9. this complete distance is 1.9. this complete distance is 1.9 and this is 0.99. so the whole distance is basically 2.34 from this place to this place. So you can measure up to second resolution, any measurement up to second resolution from this scale, like of diagonal scale. We can use diagonal scale similarly, but this is also a special scale which you can use. So this is called a backward vernier scale. Okay, I think you had understood everything about vernier scale. Now in this video I am going to explain you the second last question, which is based on the forward vernier scale. As of in the previous question, RF is given to you and maximum length is given to you. Everything would be same. You have to calculate the LOS. In case of backward vernier scale, we used to take 11 parts of the base scale, and in this scale you have to take 9 parts. So you will see the magic, what's the way we will calculate. First, the RF is given to you. RF is 21 by 2500. So next would be maximum length. Maximum length is given to you as 300 meter, and so LOS you need to mark a distance of 157 meters. Need to mark 157 meters. So LOS would be 1 by 2500 into 300 meters, means 1 by 2500 into 300 into 100 centimeters. So this would become 12 centimeters is LOS. So you need to make a line of 12 centimeter like this. This is 12 centimeter line which is representing 300 meters. Which is representing 300 meters. So this is 12 centimeter line representing 300 meters. So we need to make the division, 3 division of this line, only 3 division, because of 300 we need to make 100 meters division. So 1, 2 and 3. Now you should join the last division with the corner point of this line like this, and then you fix your scale, make a parallel line like this. Then you will get a equal 3 division in the box. Three equal divisions. Now you have to make again 10 division of the first box. So take any angle from this point and mark 10 divisions on this line. Small division should be there. 1, 2, 3. This is 10 division. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now you join last arc with the corner, with the bottom corner, as you can see. Then you have to make parallel lines, fix your scale and make a parallel line over here. Again a parallel line. Okay, so these parallel lines you have to mark them. Making it 10 perfect divisions. So almost it is perfect, but still there is some misalignment is there. Now you should take 9 boxes and make a 5 mm box again. 9 boxes, like in the previous question we had taken 11 boxes, 11 divisions. Now we have to take 9 divisions, and then we will make a box over here. You need to divide this box in 10 division again. So you can divide from here or from here, no problem. Any side you can take. Now you have to join the last point with the arc, the last arc. This is the 10th arc. Even a slight mistake, can bring a very big error. So that's why you have to be very careful when you are drawing such things. So whatever the division we will get, it is always behind this. It should be always behind this. So if you are perfect, then all the divisions should lie just behind the below division, the division below it, just behind it, because it is 9. So there is an error, that's why my divisions are not matching. So you have to make it accordingly. Some divisions are not matching, so you can, because I am using pen, you have to make it accordingly. So this is a 300 meter segment. You can write it over here. This is meters, and this is 0, this is 1 and 2, and this is again 0. Oh sorry, 1. This is again 1. This is 1. So yeah, now we have to find out 157. In the table of 9, if you write 9, 18, 2, 7, 3, 6, you should increase the number and you should decrease from this side. You will get the 9 table. So this is the beauty of a 9 table. Every digit come into picture, like 4, 5, 5, 6, 6, 7, sorry, 5, 6, and this is 6, 5, 4, this is 4, 6, 5, 4, then this is 3, 2, 1. Now 6, 7, 8. So all the digits 9, 8, 7, 6, all the digits come into this place, and we have to subtract, we have to eliminate the last digit of any dimension. Like this is 100 meter, then this would be your 10 meter distance. This is 100, 100, 100, 300. So this would become 9 meter. This is 10 meter, this is 9 meter. So need to subtract 27. In order to eliminate 7, 27 has to be used. 9 table, you have to use 9 table, and earlier question you have to use 11 table. So in order to find out the dimension on the scale, you need to eliminate this last digit. So eliminate by 27 and remaining would be 130. 130 plus 27 is 157. Here this is subtraction, is this addition. So we need to find out 27 is 9, this is 9, 18, 27. So this is 27, distance would be 27. The distance here from here to here is 27. We need to make 130. See, this is 100, this is 100, so we need 30 more. We need 30 more distance, 30 more points, 30 more divisions. So need to make again division on this part for calculating one dimension only. So just make it again, line at any angle, then make a 10 division again over here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now you need to close this as previous method. Now you tight your scale and then parallel lines. You need to make vertical lines. Okay, now we need 130. This is 100, this is 100 meter, this is 100 meter. Now we need 130 more. 1, 2, 3. We need 130 more meters. So this would become, this is 30 meter. So the total distance from here to here would be 157 meter. This is 157 meter is calculated. Any distance, like you can take any distance like 94, like you need to take more than 100, because in order to make 94 we have to divide this part also. You can say anything 123 meters, like 123 meter. So 123 means you need to eliminate 3, so you will get 63 elimination, 63 subtract 63, so you will get 6.0, oh sorry, 60 plus 63. This is, you are getting 60 plus 63 is 123. 60 plus 63. So 60. Another, you have to make division of this part, and you take 6 part from this position, and 63 is coming out to be 1 2 3 4 5 6 7 8 7. So you need to take 1 2 3 4 5 6 7 division from here and 6 division from here, like 1 2 3 4 5 6 7. 9 sevens are 63. So this is 7 8 9 and 10. 7. So you take this point like this. This is 63. This up to this point it is 63, and you need to take another 6 division, which I will not draw at this time. This is 6. This total would be 60, and this total would be 63 and 60, and this total would be 123. So this is how we will calculate all the distances possible on this vernier scale. This is called as forward vernier scale, and you have to draw only one dimension in the paper. You will not get to draw 2 dimensions, because you have to make all the divisions, so you will get only one dimension to be presented on this scale. You will not get 2 dimensions, because that will make it more complex to make. This is forward scale. Forward vernier scale. Okay, this completes your vernier scale. Now the next video would be for isometric scale. Now this would be the last question of the scale assignment. That would be the isometric scale. For isometric scale, you don't need to follow this RF and maximum length. So you need to make only an isometric scale. You don't need to make a plane scale on isometric scale. This is basically a plane scale over isometric scale. You need to draw just a 10 centimeter isometric scale. So how to draw that 10 centimeter isometric scale? You just need to make a straight line, any length. Then you have to make 2 angles. One is 30 degree. 2 angles. One is 30 degree and one is 45 degree. 2 angles you have to make. Take your scale. This is 30 degree and 45 degree. 2 angles are required to be made. And on 45 degree line, you take any distance. And you should draw a 10 centimeter scale. Start from any distance. 1 2 3 4 5 6 7 8 9 and 10. You need to mark 10 centimeter length and 1 2 3 and the separation of 1 centimeter by using actual scale. Okay, then you should draw a vertical lines like this, These are vertical to the baseline. You should always remember all the lines are vertical to the baseline. You have to rub this line, and you just need to make up to this 30-degree line. I am just showing you how to bring these lines downward, but you have to draw until this line, this 30-degree line. You don't need to draw up to bottom, just need to draw up to this 30-degree line. Then you have to take your scale and approximately you need to make a box which is parallel to 30-degree line. You need to make a box like this, approximately 5 mm box. You need to confirmly make it parallel to the 30-degree line, and it has to be up till until the point 10. It is slightly bended from the. You need to make this box on 30-degree line. The starting of the box is from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The box starts from 1, and you need to find out the point. You need to find out the vertical point of this one. This is 1 dash, this is 2 dash, this is 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, and this is 10 dash. This generated scale is called as isometric scale. You need to write it over here. This generated scale, obviously if this is 10 mm, then this would become something reduced value. The reduction factor here is 0.822, is fixed in isometric scale. 0.822 is a fixed reduction factor in isometric scale, and the generated scale, which is this is called as isometric scale. Isometric scale. This is, you need to show this 30-degree line, and this is 45-degree line, and you can also mention over there, this is called as main scale. So we have generated isometric scale by using main scale or actual scale. This is called as main scale and isometric scale. This is the whole story of this isometric scale, 45-degree and 30-degree. This is the complete isometric scale. Nothing you have to draw. Whatever dimension we will take it from this. So the reduction factor from this to this is 0.822, 82%. If this is 10 mm, this would become 8.22 mm. This is the reduction factor. So that finally completes your question number 6 over here. So you have to draw all these scales on the sheet, and if possible you need to draw the questions also. In order to write the questions, like something, the question is given to you, you need to make this line in the separation of 5 to 7 mm, and then construct in a proper separation. Construct a plane scale. You are writing like this in the forward 5 to 7 mm distance. You need to have 7 mm distance, but the height of the word, the height of this word, this whole word, this whole writing should not exceed 5 mm. Plane scale. There must be a gap in this column. Width RF 1/400, and likewise you have to write a whole question with these problems. All the problems you have to write the question also. Question number 1 like this, question number 2, question number 3, you have to write questions also. Okay, that would be the proper way of doing all the scale assignment.